This video is intended as a brief reminder of how we graph in a Cartesian coordinate system. The first notion that we need to understand is the notion of an ordered pair. If I just talk about a pair of numbers, the pair of numbers 2, 3 is exactly the same pair as the pair of numbers 3, 2. That is, they're both just numbers, and one of them is 2 and one of them is 3, and the order doesn't matter. We're going to distinguish that from the concept of an ordered pair. In an ordered pair, we make a distinction between the first element of the ordered pair, which we'll place on the left, and the second element of an ordered pair, which we'll place on the right. In this case, the first ordered pair here represents the ordered pair 2 is the first element, 3 is the second element, while the second ordered pair represents the ordered pair 3 is the first, 2 is the second. So as ordered pairs, these two pairs are not the same. 2, 3 is distinct from 3, 2. Now we're going to be graphing ordered pairs of numbers in something called the Cartesian coordinate system. And the Cartesian coordinate system is a system of two number lines. First, there's a horizontal number line which we call the x-axis. It has a 0 in the middle. It numbers positive to the right, 1, 2, 3, 4, etc. Negative to the left, -2, -4, etc. And then it is complemented with a second number line which runs vertically and is called the y-axis. And it is numbered positive up, 2, 3, 4, and negative down. And what we do is we graph on this system of number lines in the following way. When we look at an ordered pair, the first number in the ordered pair will be referred to as x, the second number will be referred to as y. If x is positive, we will move to the right of a starting point. If x is negative, we will move to the left of a starting point. If y is positive, we will move up from the starting point. If y is negative, we will move down from the starting point. The starting point is this point in the center of the two number lines. Its ordered pair designation is 0, 0, because if you're at the starting point, you haven't moved to the right and you haven't moved up and down. So 0 units right or left, 0 up and down. And we call it the origin. Origin simply means starting point. So how would I graph, for example, the ordered pair 2, 3? Well, since 2 is positive, that means we would go up from the starting point 2 units. Since 3 is positive, since 2 is positive, that means we would go right from the starting point 2 units. And since 3 is positive, we will go up 3 units. So 2 to the right, 3 up would put us right here. And so that would be the point 2 to the right, 3 up. If I were graphing the point -1, -2, the -1 for my x number would indicate 1 to the left. The -2 for my y number would indicate 2 down. So I would start at the starting point right in the middle and go 1 to the left, which would put me here, and then 2 down. So this point would be the point -1, 1 to the left, -2, 2 down. Crossing the two number lines divides the plane into 4 parts. We call the part quadrant 1, quadrant 2, I'll just put a Q for quadrant, quadrant 3, and quadrant 4. 4 quadrants numbered counterclockwise starting with the upper right. It's kind of like you have a rotation from one quadrant to the other that goes around counterclockwise like that. So where would a number whose first number was, or an ordered pair whose first number was positive and second number was negative go? Well, again, the first number designates right to left, so if it's positive you move right. The second number is up and down, so if it's negative you move down. So if you were starting at the starting point, you'd move to the right, which would be this way, and down, which would be this way, so you would be in quadrant 4. So you can tell what quadrant a point is going to lie in by just looking at the signs of the two numbers. Now what we're going to be doing is we're going to be graphing functions, and we've already talked about what a function is. If you pick an x and you only get one y, we call that a function. If you take a look at this first example problem here, y equals 2x plus 1, that's a function. For example, if I pick x equals 5, 2 times 5 plus 1 is 11, so the only number I get for y is 11. That makes it a function. Now, the way we graph a function is we set up what's called a table of values. A table of values is just a series of points that satisfy the equation of the function. Now, instead of writing all our points like this, which is kind of a whole lot of writing and time consuming, when we're doing a table of values, we just usually represent a T-shape. So if I want to put a point, say 0, 1, I want to graph that for my function, I'll just put 0 for x, 1 for y. And that way I don't have to write parentheses and commas every time I want to add a new point. Now if you're graphing a function, what are some of the keys? Well, first off, you have to know the basic shape. And we will be studying these lines later, but when you have something that's in the form y equals mx plus b, that is always going to be a line. And in math, line means straight line. Always straight line. If a line isn't straight, we refer to it as a curve in math. And this is in the form y equals mx plus b, so we know it's a straight line. And since 2 points determine a straight line, we only need to know 2 ordered pairs x, y that satisfy this equation. But I'm going to do a little more than that. I'm going to graph about 3 points to the right of the origin and 3 points to the left. So for my 3 points to the right, I'll graph 1, 2, and 3 for x, and to the left, -1, -2, and -3, and that'll give me a look at the graph on both sides of the origin. I already suggested that if you use x equals 0, you get y equals 1. You can see that right here. You could go through the empty hole method if this is more complicated, but this is so simple. We'll just replace the 0 with the x, and we get 2 times 0 plus 1, which is 1. Now if I go to x equals 1, then this is 2 times 1 plus 1, so that's 2 plus 1, which is 3. If I go to the x equals 2, that's 2 times 2 plus 1, which is 5. And if I go to x equals 3, that's 2 times 3, or 6 plus 1, which is 7. Well, those are off my graph. I only extended my graph to 5, so I'll just have to drop that one. I won't be able to fit it on the graph. Let's try some negative values. You always want to try to get some positive and some negative. If I let x be -1, this is 2 times -1, that's -2, plus 1, so I get -1. If I try -2, 2 times -2 is -4, plus 1 is -3, and if I try x equals -3, I get 2 times -3 plus 1, which is -6 plus 1, which is -5. So I'm now ready to graph. The first part goes 0 to the right or left, 1 up. So that would be right here. The second part, 1 to the right, 3 up. 1, 2, 3. That would be right here. The third point, 2 to the right, 5 up. 1, 2, 3, 4, 5, right here. And you can see that these are starting to line up in a straight line. And if one of these points turns out not to be on the straight line, then we have to assume that what happened is, since this is the graph of a straight line, that we've made an arithmetic error. Okay, the next point in our list is 1 to the left, 1 down. That lines up well. 2 to the left, 3 that lines up well. And 3 to the left, 5 down, that lines up well. Now the straight line doesn't stop here. These are just the points we used. So to indicate that the straight line keeps going, I put arrowheads on each line. And that is basically how we graph. Now this is a graphing calculator class, so in the next podcast we will extend this graphing to how we use the graphing calculator. That completes the podcast.